What is up, Tube? Welcome back to Loguido's Chop Shop, the second best gel blaster channel on the tubes. And today I have got a whole lot of Lonex. Parts, and I'm going to be unboxing all of it and building a gearbox. Now, all of this Lonex stuff is available from Tactical Edge Hobbies. So, first of all, let's get down to business. If you don't know what Lonex is, Lonex is a company that produces high quality airsoft components, and for a lot of our gel blasters of the V2 variety and similar sorts of other internal bits, they're very similar in a lot of circumstances, even just replaceable with the airsoft components. So it's mainly just the gel projectile which kind of separates airsoft from gel soft. So let's have a look at what we've got here. We've got an M110 spring, a 95% cylinder, a extreme toughness piston, cylinder lubricant, silver plated wires, cutoff lever, trigger, a motor. I'll get into that a bit later on when I see the specs. We got an 18:1 gear set, anti-reverse catch, O-rings, piston head, bearings, spring set, and a trigger switch trolley assembly. Now, probably the component which is missing, which I don't have, is a gearbox and cylinder head. So I will provide a gearbox and a cylinder head. Unfortunately, I'm waiting for another company to manufacture their V2 box, but while that is happening, I'll whack this stuff into a War Interest box just to see how we go. Now, of course, I've got the War Interest box and the plate, the selector plate, which are two of the pieces that I don't have. Let's get going. Okay, let's start with the wire. This is some silver plated wire. Now, it's probably not the most exciting place to start for some people. It might not be all that exciting, the wire, but I'm actually pretty interested in the wire. I'm trying to find the end of it. It looks pretty good. It looks like a reasonable gauge of wire. And let me just get a bit of the insulation off so that I can have a look at the actual wire without any insulation on it. Alright, so that looks like some hefty gauge wire. Let me just get a measurement. Okay. .3 millimeters. Now, I happen to have here, this is a piece of the silver wire that you get when you buy like your generic Chinese silver wiring kits. I'll just see what sort of gauge we're looking at there. 1.08. So you can tell, I mean, I could tell just by looking at it, but you can tell the gauge of the Lonex wire is a bit thicker than your average sort of silver wire from the Chinese silver wiring kits that you buy. And wire gauge is important because obviously the thicker the wire, the more current it can handle. And if it is indeed silver plated, then silver is the best conductor in the world, so you're onto a winner, I'd say, with something that thick. Now, the only problem with having a nice thick gauge wire like that is that it makes it difficult to run into the little, nooks and whatnot of the gearbox. But we'll see how we go. It looks pretty nice because I think the insulation itself is not that thick. Like I think we're only looking at like 1.8, 1.9 maybe millimeters with the insulation, and then 1.3 on the wire itself. So the insulation isn't that much thicker. Sometimes with some of the wires you get, the insulation's really thick, and then the wire inside the gauge is actually quite thin. So that looks like some good proper quality wire, so we'll use that. That'll be good. Now next, cylinder lubricant. Now this I found quite interesting. Cylinder lubricant. Looks like a grease rather than an oil. Yeah, okay, interesting. I don't like using grease in the cylinder because it can actually clog up your O-ring and your piston head and start creating vacuum. So I prefer to use like a light gauge oil, which still gives you the lubrication but it doesn't clog things up. I would have expected that to be gear lubricant, but it does specifically say Lonex lubricant for O-ring cylinder. Alright, well, we'll go with that. We'll see how we go. Like I said, I prefer a oil to use in the cylinder on the O-rings rather than a grease, because the grease tends to cake up a bit. But there we go. We'll see how we go with that one. Starting off with all the least interesting things. Spring set, pretty standard sort of spring set. You got your anti-reverse latch spring, your trigger spring. This is the selector plate spring, and I'm not actually sure what this one is here. I think it might actually, I think that one might, oh, safety, that's a safety. That's a safety spring, and what else is in there? The tappet plate spring and the, I think that's the trigger trolley return spring in there as well. So I've got all of that. Interestingly enough, a lot of those springs also come with the other parts. So like the anti-reverse catch comes with a spring as well, and I'm pretty sure the trigger trolley comes with a spring as well. So some of those springs we won't actually need, but a lot of them we will. So that's handy still to have. It's always good to be able to buy these sorts of things in a packet. Like I like being able to buy the springs separate, because springs is the sort of thing that like jump out of the box and you lose them, and then you try to put the box back together, you don't have all the springs and whatnot, and so it's always handy to have spares. So I do like being able to buy a pack of springs, just having all the springs you need to get the job done. That's pretty cool. Trigger. Alright, looks like a aluminium, I'm going to say. Yep. Alloy, nice alloy, standard curve V2 trigger. I personally massive fan of the standard curve. I know you can get the triangle ones and the straight ones and the all that. I just like this. I like this traditional standard curve. Again, comes with a spring, trigger spring, so that's in addition to the one that's in the spring kit. So again, we'll have a spare, which is good. Bearing kit. Now this is a set of 7mm bearings, I believe, and I'm going to be using a box with 8mm bearings, so I probably won't actually use these. These would fit your J9, Gen 8, J9 type blasters. Yeah, 7mm. So not gonna work for my 8mm war interest box or most other V2 style boxes usually have 8mm bearings, so 7mm bearings is an odd choice. They'd be alright though. I'll probably keep them for a J9 or something like that. J9, Gen 8, one of those. They'll work in that. I don't know why they would have provided me with 7mm bearings. That's an odd choice given that most boxes use 8. But anyway, I'll put them to good use. Trigger trolley assembly. This is the trigger and the trolley. Now, if you don't know what this is, again, it comes with a spring and the mounting hardware, which is good. This is what actually activates. This is the electronic switch that activates your blaster. So you got this metal tongue on the trolley here. I don't know if you guys can see this. Maybe I should light this up a bit. Is that a bit better? So you got this metal tongue here, and then these two blades, and the tongue gets squeezed between those two blades like that, connecting them together, thus completing the circuit. So you have these metal tabs here, here and here, which is where you will solder your wires on, there and there, and then that's your switch basically. That's on, that's off. Circuit open, circuit closed. And that's what actually, your trigger actually sits below this. And in fact, let me get that trigger. Trigger actually sits just here. And it sits under here and pushes that trolley forward. When you, it sits in there, pushes that forward. And then when you release it, this spring here, which sits on the top there, pulls it back. Interestingly enough, it's not physically attached to the top like that, because your semi-fire select mode, the way it works is it actually just knocks this off the top of the trigger. So you have to release the trigger, go back. That's how that works. So your semi works by just basically knocking that little trolley off the top. So new trigger, trolley assembly, all good to go, because that's handy because I don't have one, because this box is empty. If you're starting fresh with an empty box, you will need one of these obviously, or alternatively you could use a fire control unit MOSFET or something like that. I'll be using this because I don't have a MOSFET. Now, speaking of the trolley, this is actually the cut-off lever which knocks the trolley off the top of the trigger. This little hook just down in here actually hooks under that trolley and lifts it off the top of the trigger when the cam hits this end here. So this is like a little rocker arm basically. Incidentally, again, it does come with the spring, which goes on that side there, which works with your selector plate. So when it's in auto, basically this is out of the way, doesn't really do anything, and then when it's in semi, it's pushed back under the trolley, and then the cam on the sector gear pushes that piece there. And it's metal alloy. Looks like a cast alloy. I like the metal ones because the nylon ones can flex, and sometimes your semi will become full. Just does. And that's a thing that particularly the nylon boxes and that sort of thing are renowned for, if they've got these nylon cut-off levers, is that your semi becomes auto, just especially once you start upgrading things. I've got the 95% cylinder, which is an interesting choice of percentage. 95%. It's probably good enough for a oh, if I can get this out of the plastic, good for a long barrel, longish barrel, mid to long barrel, like 27 to 30, around there. I can get this out. Wow, it's in there good. Alright, so we've got the nice sort of ribbed finish there. You can see the ports on the back here. Of course, that's going to be the back of your cylinder. Your piston's going to go in here. This was your gearbox. It'll go in this direction. Don't put the ports to the front. I've seen that. I've seen people do that. They put the ports to the front of their gearbox and then they're like, why have I got no FPS? Ports always to the back, because that's where your air leaks out basically. So you get compression from this point onwards in the cylinder. I think, is that a steel? Feels like steel. Oh yeah, yeah, nice solid magnetic. I think that's a steel cylinder. Looks quite nice. Black, I like black. Bit stealthy. Alright. Next we've got the Extreme Toughness Piston. Now this is a bit of a bone of contention. I'm not a fan of having these teeth here, these first few teeth in the polycarb, and then metal teeth onwards. Now I can understand for weight saving. I've seen a lot of pistons where they have like 1 or 3 teeth that are metal towards the end, and then the rest of them are just nylon or a polycarb. This is polycarb, so it is pretty hard. So it might be alright. I mean, we're going to run with it and see how we go anyway. I am not a fan of running combinations of plastic and metal. If you've got metal gears, I think all your gears should be metal. If you've got plastic gears, then all your gears should be plastic. That's my personal opinion. I know that in the airsoft circles, a lot of pistons do start with these first few teeth nylon. Obviously the high stress end is this end, because as the spring gets drawn back, you're under the most tension when it's on these last teeth. So I understand that. I'd just prefer it to all be metal personally. But you know, as long as we get something meshing up well here at the start, and it should be good. We'll see how that goes. Anyway, to complement that, there is a POM piston head. Now, POM is a poly piston head. I forget the exact acronym of what it is, but basically it's not an aluminium head like some of the ones you see on gel blasters, but this is a poly head with an aluminium shaft through the middle. I noticed that the vent holes are very small. They're quite large on the outer, but then by the time they get through here, they're very, very small. So I might whack that on the manometer when I've got it chucked together, just to see how we look on that. But I think I'd prefer these holes to be a little bit bigger for gel, particularly because if you get too much vacuum, you can suck gel back into your cylinder, which is no good. But we'll see how we go with that. We might make some modifications to it. Easy enough to do, but that will accompany this. Okay, we got an anti-reversal latch. Now, this thing might not seem that exciting, but very important. Stop your spring from pushing the gears into reverse. And a spring, again, comes with its own spring. Looks like it's a high quality metal. Actually, let's have a look at the gears next. Because speaking of high quality metal, these are the gears. The Lonex gears. Now these look really nice. Like in terms of quality. I don't know if, let me zoom in on these. Alright, look at these. Can you see this? This is a really nice looking, high quality, hardened steel gear set. Except, what's going on here? So this is interesting. I'm not sure if this is to save weight or to make it a bit easier on the piston, but it seems like they've got these really hard steel. These are machined too. I don't know if you can see this. This is machined. This spur gear is machined. I can see machining lines in it. That could be machined. I'm not 100% sure about that one. But this is sintered. The sector side of the sector gear, and then it's and then this one is, it's like it's looks like it's press fit, interference fit onto the sintered sector is a hardened steel gear to mesh with the spur there. So maybe this is a weight saving thing, using maybe a lighter alloy of some sort. I don't know, but it certainly looks like nice high quality stuff. Another interesting thing I did note. Yeah, these are definitely machined. These are machined. They're turned between centers. You can see on the end of the shaft how there's center holes. So these are turned between centers. This is also interference fit here, so the actual gear, the outer gear, is interference fit over the shaft with the inner gear. So the inner gear is one piece, and then the outer is another machined piece, which is then interference fit over there. Same with the bevel. This little spur here is actually interference fit into the bevel. All very interesting stuff, but not half as interesting as these. Let me get back out again. These are O-rings, and I don't know if you can read the packet, it's too much shiny. They're hollow O-rings. So I've never seen this before. That one's a bit scuffed. But in here, so let's zoom in again. So I don't know if you can see this on the camera. I'll try and point it out to you, but in here, this is actually hollow. It's like not a round O-ring. They call it a hollow O-ring, but it's sort of like a D shape, I guess, with a hollowed out inside. Now, I'm assuming that under compression, the air coming through the piston, the holes in the piston, actually goes in behind here. And I suppose that's supposed to create, to force it out, to create a better seal. I've never seen anything like this before, so I'm pretty keen to try these out and see how they go. Incidentally, this one here I should point out as well, because you've got to take the good with the bad. Despite the fact that Lonex is very high quality stuff, you can see this one missed the QC a little. There's a little casting issue on that one. No biggie. You can get a knife and slice that and sort it out. But the rest of them are fine. Just one seemed to be a little bit odd. It's got some marks. I guess when these are manufactured, they're probably sort of cast in a group like that, and then they're split or something. And this one, I don't know. There's the manufacturing error, slight manufacturing error, not a big deal, but I probably would have expected something, like that should have been picked up in QC. Anyway, let's move on to the most interesting part. Okay, the motor. This is what I like. I like electrical stuff. Now, there's a range. It's got specs. It's got specs on the back of it. So there's a few different varieties: A1 plus, A1, A2, A3. So there's infinite torque up and high speed, infinite torque up and high speed, infinite torque up, infinite high speed. So there's A1 plus, A1, A2, A3. They're the models that they go by. Now it's interesting that A1 plus, they specify you can use a M140 spring, an M150 spring, or M170 spring, or an M190 spring. Whereas, say, like on the high speed, they specify M120, 130, 140, 150. So, this particular one, going by what it says on the motor, it's an A2. So that's the torque up, infinite torque up, which is this one. So they recommend M130, M140, M150, and M170. Given that we don't generally use anything that strong, we're going to be using the M110. I think this motor should be plenty torquey to pull the M110. Let's get it out of the box and have a squeeze. I like motors that have got specs, because a lot of the time they don't come with any specs. Although I don't know exactly what. It doesn't tell me how many turns on the armature or anything like that. At least not yet. Oh, this is cool. Okay. Hey. It's got a full little chart with all the specs. It's got RPMs, torque, power output, every single little bit of specification that you want. It's got specs there that I don't even understand. Torque. Oh no. Okay. I was gonna say I don't know what a kg stands. Kilograms per centimeter. All right. That's how they're measuring the torque. All right. Kilograms per centimeter torque. So A2. 121 watts. And 0.42 kilograms per centimeter of torque. That's at 17 amps, apparently. Oh, they actually dyno tested these and everything, according to this. They got a little dyno here. Anyway, let's get a look into the actual motor. It comes in a nice case with a soft cushion. It's got the pinion already installed. Nice. Interestingly, it's a full circle pinion. I don't know if you can see that. It's not a D shape, so there's no grub screw. This is a press fit pinion gear, so if you wanted to put this on or remove it, you'll need a special pinion pressing bit of equipment. Yeah, it looks pretty nice. Alright, I can't wait to get this into a gearbox, which is I guess what I'll be doing very shortly. First of all, I just want to do a quick little test on the manometer. Okay. First things first, get this piston head on, and as always, I'll put a bit of Loctite on this screw, because the last thing you want is when you've put this piston head on here, is any screw or anything falling out the back of that into the gearbox. Never a good thing. I'm going to put some Alright, let's get this and this and this, and we'll do some tests. Alright, so with the standard cylinder, well, the Lonex cylinder, the Lonex piston on the manometer, this has got the standard O-ring, not the hollow O-ring. So I'm just gonna test the pressure there. So it looked like we've got 30 centimeters. Push a little harder, see if I can squeeze a bit more. 31 centimeters it looked like there. Now what I'm actually going to do is I'm just going to let that equalise. There we go. Now I'm going to see if I can draw a vacuum. I think it will, because those holes were really small in the piston head, but you know, we'll see what happens. Yeah, that's quite a lot of vacuum. That's quite a lot of vacuum that moved just then. It's maybe 4 centimeters. Yeah, it came down to about here. So that's about 3.5 to 4 centimeters of vacuum, 31 centimeters of pressure. I'm going to change this O-ring to the hollow O-ring and see what difference that makes. Popped in the hollow O-ring. Now I've never seen one of these hollow O-rings, so I'm interested to see what the results are. I'm not expecting it to be any better, to be honest, but we'll see. I mean, 31 was pretty good pressure for a cylinder, 90% cylinder. That's what we're looking at there, 31 centimeters. Wait for it to equalise. Yeah, 31 centimeters when it equalises. I mean, as you push it in, it does get a spike. Alright, back to the standard O-ring again, just quickly. Just want to do a quick test on the spike. Yeah, same. Up in the 40s. Let me just, I saw, yeah, 45. About the same. Maybe the hollow O-ring might perform better with time as well. It might perform more consistently. I've not seen one before, so it's all new to me, all learning experience. One thing's for sure, both of these O-rings are definitely holding good seals. What I'm going to do now, I'll just bring up my 30. Actually, that's got. Oh wait, I didn't. Okay. Let's try vacuum. Oh, interesting, interesting. Looking like about 3 or 4 centimeters of vacuum again still. Yeah, about the same vacuum. I wanna on one part of me wants to drill the holes of this head out bigger, but the other part of me just wants to run the standard equipment the way it is, just so we can actually compare stock for stock. So I think that's what I'll do. I'm going to just run it as it comes. Alright, so now I've got all this good gear ready to go into a gearbox. But I think I'm gonna have to run a second video of building the actual gearbox up, because I'm running out of time for tonight. But all this Lonex gear looks like good gear so far. You'll have to subscribe to my channel and wait for the next video, which will be when I get to build a box up with all this Lonex stuff. Alright, don't forget, you can get all of this stuff from Tactical Edge Hobbies, all the Lonex gear, link in the description. Also, if you want to get a patch from me, hit me up on Facebook, and if you like what I'm doing here, you want to support the channel, please buy me a coffee. Also, link in the description. Peace. Alright, don't forget, you can get all of this stuff from Tactical Edge Hobbies, all the Lonex gear, link in the description. Also, if you want to get a patch from me, hit me up on Facebook, and if you like what I'm doing here, you want to support the channel, please buy me a coffee. Also, link in the description. Peace.